Hello, hello, Good morning, dear participants. Hello. Nita ma'am, good morning.
Good morning, madam.
Yes, ma'am. Yes, ma'am. Everybody is joining, ma'am.
Good
Let
morning,
us have
good
wait.
morning, good morning.
Good morning, sir. Good morning. Good morning. And we are very happy to have you all
Good
into
morning,
this.
ma'am. Good morning. Vimala from Hyderabad.
Yes, ma'am. Yes, ma'am.
Good morning.
Dear participants, my humble request you is that you can just mute your microphone and video off. Kindly please mute your microphone and video off. Dear participants, kindly Satyamangalam, Erode district, Tamil Nadu, India. I have been associated with this institute for the past 23 years. The Banariaman Institute of Technology, Satyamangalam, was established by the Banariaman Group in 1996 and is affiliated to Anna University, Chennai. The institute is accredited by National Assessment and Accreditation Council by A grade. BIT was accorded the status of an autonomous institution in 2007 to 2008 by UGC. I heartily welcome you all on behalf of Banariaman Institute of Technology, Satyamangalam, for our 7-day international faculty development program on mathematical modeling in multidisciplinary domain. The idea of putting the foundation of this FDP is so inspiring. What was once planted as a sapling is now all grown into a large tree. Here I can see a blend of extraordinary members of faculty from various states and countries who have made this day arrive. They have come to us from each and every corner of the world. The FDP aims at equipping teachers with skill and knowledge that are essential for inculcating the students and guiding and one postdoctoral fellow of DS Kothari UGC. She has traveled to USA, Singapore, Canada, South Africa, Malaysia, and Indonesia for giving talks in various platforms. She is also the Vice President of Operational Research Society of India. She is Council Member of Indian Mathematical Society. I am especially thankful to her as when we approached her and requested her to grace this morning as a resource person, Dr. Nita accepted our request and readily agreed when she looked at today's event and its program. I welcome you, madam.
Thank you.
I take great pride in welcoming all the attendees of the 7-day International Faculty Development Program on Mathematical Modeling in Multidisciplinary Domain being organized by the Department of Mathematics, Banariaman Institute of Technology. Holding such an FDP at a relatively short notice would not have been possible without the invaluable support of our management. I would like to extend my warm welcome to our coordinator of today's program, Mr. M. Karupusamy, for his tremendous support to make this event happen today. We have participants from 23 states such as Assam, Andhra Pradesh, Telangana, Gujarat, Karnataka, Haryana, Odisha, Maharashtra, Uttarakhand, Delhi, Jharkhand, Chhattisgarh, Manipur, Madhya Pradesh, Pondicherry, Bihar, West Bengal, Jammu Kashmir. We also have quite a number of participants from foreign countries such as Oman, Saudi Arabia, Singapore, Germany. Lastly and importantly, I would like to welcome all the members of faculty from various states and countries and my own institute and research students who are all integral part of this faculty development program. Once again, I welcome you all. Let's go into the presentation of Professor Neeta. Madam, it's your turn to make this day a wonderful one and a memorable one. Thank you, ma'am. Thank you.
Thank you, Professor Geeta, for giving me opportunity to explore my research on this platform. This is my first visit to South India and particularly Tamil Nadu. And I hope everybody will enjoy the current scenarios, COVID-19 pandemic, and how we can control it. So I'm setting my presentation.
Yes, ma'am. You can go ahead, ma'am.
Yeah, okay. From Gujarat, and myself and my team is working on the transmission of COVID-19. This particular talk, so title of my talk is Z Control for High Risk COVID-19 Exposed. This is teamwork of Nisa Sharon and Ekta Jaishwal. Both of them are full-time research scholars with Department of Mathematics. Ekta Jaishwal is GRF from Prime Minister Fellowship Program. The flow of my talk will be COVID-19 and infectious disease, though everybody knows now, it's almost 5 months. What is mathematical modeling? Dr. Geeta has already smoothened my work to explain what is mathematical modeling, some basic terminology used for infectious disease and its modeling. Then we will have our own area, which is modeling of COVID-19 transmissions and then chaotic nature of transmission of COVID-19. Let's start. COVID-19 has its birthplace in Wuhan and birth date is December 19. On 30th January 2020, WHO declared its outbreak as a public health emergency of international concern. Worldwide, it has caused 47,249 deaths and total 9 lakhs plus are the confirmed cases as on April 2nd. This research was submitted on 4th April. So this data is up to April 2nd, 2020. And according to IST time, 8 o'clock morning. COVID-19 spreads through the contact of an individual with an infected person when they cough or sneeze. This cough is cold cough. It is a respiratory disease with mild to moderate symptoms with dry cough, fever, tiredness, and in more severe cases, difficulty in breathing. This happens particularly for aged people, and that's the reason why central government has imposed not to go out for individuals with 65 plus age. Also, few of them showing mild symptoms of the disease may recover themselves if they avoid contacting others and maintain good hygiene. So this says that we don't have to be panicked. Some of the mild symptoms like a cold goes off within 7 days. So similarly, this COVID-19 infection may go even if you go for home quarantine. COVID-19 is a major health threat to the person underlying past medical history and also to those who are 60 years old, what we define as elderly population. And we know 40% of population of India comes under elderly population. The study calculated median age of 425 patients infected with COVID-19 in Wuhan, China as 59 years. And almost half of the patients were 60 years old. This is quite obvious because they have reduced immunity and most likely to get the infection. So government throughout the world are taking several preventive measures in order to control the spread of the pandemic. As preventing the spread is the only way, since no vaccine is known, even no medicine is known till date to fight the virus. Preventive measures include maintaining 6 feet distance between you and person, sneezing or coughing, even a normal person, washing hands regularly, maintaining social distancing, etc. Because in India, we are considered to be the fond of social gathering. But now this COVID-19 has put restriction on us not to have social gathering, or another way, we should maintain social distancing. Early study concluded that with the basic reproduction number 2, this is very early, like December 19, and considering 14 days infectious period. And what infectious period means, a person exposed to infected person is kept in quarantine, home quarantine or COVID center quarantine for 14 days. And then if no symptoms occurs, he can be freed. If an infected person stays for more than 9 hours, he could infect others. So if you are staying with an infected person for more than 9 hours, you are likely to get exposed and get infected. But on the other way, relief is, if exposure time is 18 hours, the model recommends full protection with more than 70% effectiveness to the attendees of the social gathering. Now, this is not the case at present. It may happen from today onwards because now India is unlocked. In order to control the disease, the importance of travel quarantine, that is what we had since the beginning when we airlifted NRIs either from Wuhan or from Georgia. Recently, we had airlifted from Dubai, US, UK, Singapore, and many more countries. Not only travel airlifts, even interstates. So in order to control the disease, the importance of travel quarantine or travel restriction globally may delay the progression of disease. From the study so far, we have observed quarantine or isolation plays a vital role in controlling disease spread. While India could control disease only up to, today's news says, up to 1.9 lakhs, it's only because of early lockdown in India. So in this talk, we'll discuss a model with Z control applied to quarantine class so as to get the required exposure state, which will help in controlling the disease from the chaotic scenario in elderly people. Now here chaotic scenario means we take proper actions. We put our elder people home quarantine. No doubt it is very difficult to ask people to be at home, but if we do that and we are successful also, so that they can be kept at home and hospitalization will decrease. What is mathematical modeling? Now that already it has been explained by Dr. Geeta, but I'm just doing some of the more steps which I want in my talk. Mathematical modeling is a tool to understand biological mechanism, because we are working with virus. So I'm saying biological mechanism of a parasite involved, or to measure the relevance of any public health care strategy on a large population. In particular, mathematical models can be used to visualize the transmission dynamics and the spread of this disease. Most of the time, we always ask, or press also asks, media also asks, when the COVID-19 spread will decrease. So that's what we can have prediction. It is not confirmation. So mathematical tools and mathematical model can help us. These models can help us to understand the right disease status and predict if the disease is going to be epidemic or will die out in a short duration. Epidemic in the sense that it will not go away, it will remain in the system, it will remain in the society, and die out means there will not be any cases of COVID-19 in short duration. But that is not the scenario at present. This analysis can be highly helpful to the society, particularly health department, if utilized properly, and it can helpful to society if all the rules and regulations are followed without having any complaints. Understanding the transmission dynamics of disease spread will not only help us to control the disease, but will also make us prepared for the future, as it will make the scenario and intensity of spread clear. Some of the basic terminology for modeling in infectious diseases are susceptible. Who will be considered as susceptible? A person who is not infected but is at a risk of catching infection. Then next category is exposed. A person who has contracted the infection but symptoms are not visible. And at present scenario in India for COVID-19 transmission is there are more individuals who are asymptomatic and turning out to be COVID-19 positive. Infectious, a person who has the disease with symptoms and is capable of passing infection to the others. Recovered or removed, we use these two terminology in a two different way. Recovered means after treatment, symptoms are gone. That is the 3 consecutive COVID-19 test turns out to be negative. They don't have temperature for consecutive 3 days, and the person is relieved from the hospital or from the home quarantine. So that says that person is no more infectious. And removed can be death. Death here, because I said that we are only taking care, this model is considering care of elderly people. So removed in the sense they have death because of comorbidity. Comorbidity means the person who had already disease got infected with COVID-19 and that has occurred. Incubation period is the duration between exposure to the infection having first apparent symptom of the disease. And incubation period from COVID-19 varies from 7 days to 14 days. Okay, now what about the status of the disease? A disease is said to be endemic if it is regularly found in population, like malaria, okay, in a particular population or particular area. Epidemic, a disease is said to be in epidemic stage if the number of cases substantially increases within a short duration in a given population. So question comes, can we say COVID-19 to be epidemic? Answer is yes. But it also has one more terminology. We call the disease to be pandemic if it is prevalent in the entire, not only in the entire country, but...
Excuse me, ma'am. Excuse me, ma'am.
Yeah.
Ma'am, your screen is not visible here. You present your screen, ma'am.
Okay.
Okay, ma'am.
I'm rephrasing.
Yeah, ma'am.
Just a minute.
Yes, ma'am. Yes, ma'am. Now we are able to see your presentation.
But in that case, I am not able to see my presentation. I need to think,
Have you presented your screen, ma'am? Have you presented your screen? Ma'am,
Yeah.
we are able to see it. We are able to see it, ma'am.
But I am not able to, just a minute.
Okay,
I'm stopping it for just a fraction of a second because I'm not able to share my screen.
Okay, ma'am. Okay.
Can you see? Can you see
Yes,
now?
yes, ma'am. Yes, ma'am. We are able to see it.
Okay, done. Clear?
Yes, ma'am. Yes, ma'am.
Yeah. Now, as the world is very well aware of COVID-19, we don't have to say anything about it. And everywhere, the respective government is carrying out necessary measures to control the spread or human-to-human transmission of COVID-19. That is, we are also taking care of community transmission of COVID-19. The best way to visualize the importance of measures being taken is to analyze it by introducing optimal control theory and tool is Pontryagin maximal principle into the model. Mathematical compartmental model for the individual already suffering from diabetes or hypertension who are at higher risk of getting COVID-19 is under consideration. We will be having 3 mutually exclusive disjoint classes: susceptible, exposed to COVID-19, and quarantine class. So let's see what his model here is. So here we have 3 compartments. We call it compartments or subpopulations. S stands for susceptible, infected with diabetes or hypertension. So we are talking about elderly people. Elderly people doesn't mean only age-wise. If they are suffering from diabetes or hypertension, they will be kept in susceptible group. Then we have exposed to COVID-19, and the next class is quarantine. Okay. Now we have mathematical model. So what to do with next step? Here we are with next step. At what rate every individual is moving from one room to another room? So beta 1, B is birth rate. Beta 1 is transmission rate of individuals from susceptible class to exposed class. Beta 2 is force of infection. Beta 3 is rate at which exposed individuals quarantine themselves wisely. Okay, and we know that we need to do something. Beta 4 is rate at which susceptible individuals quarantine themselves. And these are some half saturation constants, A, B, and D. So now we have rate at which individual is moving from one place.
It's coming. Yes. Now it is coming.
Okay. Now, rate of change of individuals in susceptible class is given by this nonlinear differential equation. Rate of change of exposed is given by this equation, and similarly for quarantine. So we are in R3 manifold. We are with a system of nonlinear ordinary differential equations. What to do with this? So we have tool which is known as basic reproduction number, and it represents the number of individuals.
Excuse me, ma'am.
Yeah.
Ma'am, again your screen that is not visible, ma'am. And somebody who have joined now, they've shared their screen. That's a problem. Dear participants, kindly mute your microphone and video off. Also, you don't try to present your screen while the presentation of madams is going on. Please try to cooperate with us. Only then we'll all be able to enjoy the session. Thank you.
Is it visible?
No, ma'am.
That means I will have to do once again. Okay, let's do. Okay, just a minute.
Dear participants, please mute your microphone and video off. And kindly don't try to present your screen while the presentation of madams is going on. Please kindly cooperate with us. Only then we all will be able to enjoy the session. Thank you.
Can you see?
Yes, ma'am. Now it's visible, ma'am.
Okay. So we were at basic reproduction number. It says who are asked to quarantine themselves or go for social distancing by a single individual suffering from diabetes or hypertension. Normally, we bifurcate this as a normally elderly people who are exposed to COVID-19. This helps to predict whether the disease will spread in society or die out. This rate is affected by several factors, including the time duration of effect, that is for how much time it is going to be there, 14 days we said, the effectiveness of the issue, how severe symptoms are, the number of susceptible people with whom the affected people come in contact. So this contact rate plays a vital role. Okay. Now, why it is useful? If it is less than 1, that is reproduction number is less than 1, the disease will die out in short span of time. This is not the case at present. If it is greater than 1, then more and more individual in the population will get infected. So we are with this particular scenario. The threshold of the dynamical system is computed using next generation matrix method. One can get go huge amount of literature on how to get next generation matrix method. And the this next generation matrix method consists of two matrices, F and V. F is the matrix of newly recruited individuals and V is transferred matrix of derived individuals. And V says it should be non-singular because we want FV inverse. And spectral radius of this matrix FV inverse is defined as reproduction number. Now, what is spectral radius? That is the largest eigenvalue of matrix FV inverse, only real part. Okay. So for the model, what we said in R3 module is having F and V like this. Okay. So now I know what is reproduction number? That is how many people will get infected by just one infected person. I also should know when the system will turn out to be stable. So we need to go with stability analysis. And that's a property when the system disturbed from a state of equilibrium, because now we are in the unequilibrium state and we are waiting for system to get it stable. That is, it should, whole country should be unlocked instead of having unlocked one and all. Okay. And third point is equilibrium point. Equilibrium point, you can solve the set of differential equation, and these points are said to be stable if all the eigenvalues of Jacobian have negative real part, and unstable if at least one of the eigenvalue have positive real part. So at present, we are with unstable equilibrium point. This I said. Okay. Here, equilibrium point is the solution of the system. There are different types of equilibrium point. Disease-free equilibrium point, not the case at present for COVID-19, and optimum disease existence, also known as endemic equilibrium point. So we will be working out with endemic equilibrium point. Okay, there are the different value techniques which one can use to find the stability of equilibrium point. One method is sign of eigenvalues, I already said. Second one, and most popular, Routh-Hurwitz technique to define whether the system is turning out to be locally stable or not. There are different ways. You can use curl, second order additive matrix, or Lipno function to define local or global stability of the equilibrium point. But at present, we don't have anything in terms of local stability or global stability. We are still fighting with endemic equilibrium point. So we have data from WHO website, and it says that reproduction number at disease-free equilibrium point for COVID-19, which was considered to be just an influenza, was 2.66. That is not the case at present. If endemic point is considered, that is at every stage, if some optimum number of susceptible who are with hypertension or diabetes or related diseases or exposed or quarantine, everywhere some optimal numbers are there, then it says 5.35 is the reproduction number. This says that one infected person can infect 6 more persons. So that should not be the criteria. In fact, at present, this reproduction number is 23. So, and that cannot continue. So we have control, which is known as Z control, which plays a vital role in reducing the chaos. And what we do, we have a system input, say UT, so that the actual system output will be forced to achieve the desired output, which is known as which is taken as YDT. And Z control is very useful if the difference between the actual output of the system and its desired output can be nullified. Namely, that we difference between them, we call it error function. As t tends to infinity, that is for a longer time. Okay, and objective function here is to reduce the error, or it converges exponentially to 0, so it will take some time, and that can be given by E dot t is equal to minus lambda E of t. This lambda is lymph node estimates. Okay, now when we apply to quarantine population, system of differential equation is same. We have one more term in quarantine people, because we said that we want to quarantine those elderly people who was exposed. Okay, so this control we want to optimize, and the purpose is to adjust the effectiveness of quarantine due to exposure. That means we want to have exposed to desired limit, that is desired limit is as small as possible. And we defined two errors. One error is taken as E1. When we want this error may not be the predicted one, so we go for the next error, that is E2, and it gives me, with some calculation, it gives me what control should be applied as U of t. Okay, now let's have because this was a theoretical portion. What our result says, we had this y-axis represents density of individuals in each compartment, and x-axis represents time in hours. So you can see susceptibles are at much higher rate. They 40, as I said in the beginning, 40% of Indian population is suffering from related diseases. Okay, so from susceptible class, we have exposed class. No doubt, it is minimum compact. Okay, and red says they are quarantined. Either they are home quarantine or COVID care quarantine, or they are counseled with 104 to be quarantined. Okay, family members might have played a vital role to quarantine elderly people. Okay, but see, with this, and it fluctuates in 200. In the beginning of the time, no doubt everybody was happy to quarantine themselves, but then it goes on fluctuating. Now this fluctuation creates periodic nature of the system between susceptible, exposed, and quarantine. And this is what we want to restrict using Z control. So here, the individuals exposed to COVID-19 are quarantined themselves or are maintaining social distance so as to avoid the catch of the disease. X-axis is exposed, that is related diseases people, and quarantine, they quarantine themselves very nicely. And this is what we have. If the population is exposed to COVID-19, by chance, they are elderly people stuck up somewhere and they got back either by airlift or by buses or by train. So this scenario will had appeared. If the population is exposed to COVID-19, more and more individual goes for quarantine, increasing the periodicity, which further turns into a chaos. Blue shades are chaos, and this chaos has occurred everywhere. It was in susceptible also. If that is quite obvious, whether they are susceptible or they are exposed or they are quarantined. In order to make this system stable and free from chaos or periodicity means they, once they are quarantined, but they may get it again. So that is what is periodicity. We apply Z control. And these are the results of Z control. You can see that susceptibles are increasing, exposed are decreasing, and that has reduced quarantine also. Decrease. Now the error function, I said E1 and E2. You can see that error function E1 was used, then we might have missed some of the exposed individuals But when you go for the second error version, it says it increases. And so that means now I should know how much control I should apply. And it says initially 20% control is required. And later on, as the exposure of disease further increases, control to be applied also increases. And that is greater number of individuals should be quarantined. That is within 16 days, it has reached to 80% from 20% initially. So conclusion is taking extra care of elderly individuals to reduce exposure to COVID-19. And this can be taken care by spending more and more time, making them engage in different activities, maybe in games, maybe in gardening activities and all. Or we can even ask them to go for the lighter home exercises, yogas, meditation, but be with them. That is what extra care aims. Self-quarantine of exposed individuals. Our exposed individuals are those who are quite literate. They themselves will quarantine themselves. They will keep social distancing. They will be on phone with their friends and all. Because self-quarantine doesn't mean that you have to sit in one room, close yourself in that particular room. No, you do all your activities, but do it from your home and apply specific preventive measures. And preventive measures, we all know, wear a mask, gloves, use sanitizers, but use sanitizers wisely, okay, from time to time. So that is what from my end, and we are still, me and my 9 research teammates are still in process of analyzing the factors responsible to control COVID-19. Over to you, madam.
Yes, ma'am. And it was a very interesting and useful thing for us, since because we are all facing the COVID-19 for the past 5 months. And I thank Professor Nita for having been made this day a wonderful one. And now, dear participants, it's your turn for the queries. And those who've got any queries, you can just unmute your microphone and you can ask and clarify the doubts of yours with Professor. I repeat, dear participants, it's your turn for the queries. Any queries, you can just unmute the microphone and ask yourself.
Hello, ma'am. Good morning. I am Vimala from Hyderabad. Hello. Hello, ma'am. Nita, ma'am. Hello.
Yes, madam.
Yes, ma'am. You are applying Z control, isn't it, madam? COVID-19.
Yeah.
What is the main advantages and what are the merits? What are the merits and demerits of Z control, ma'am? Can you please tell me?
Dr. Nirmala, merits are we can reduce the error. We can reduce the error, and that will help us to reduce the chaos and periodicity in particular.
Okay, ma'am. Reduce the error. Demerits, ma'am. Definitely each and every ma'am.
Demerits at present, I could not find out.
Okay, ma'am.
To be very frank, I am a positive person. Okay, I always go for the positive part of any research, not the negative part. What will happen if this is not there? I don't put that question in my mind only.
Okay, okay, ma'am. Thank you, ma'am. Only we have to apply Z control or some other Z transform. Yes, no, ma'am. Z control.
No, Z control is one of Z transform. If you go with the discrete case, okay, we have taken time to be continuous. Okay, but if you go with the discrete time, you can use Z transform also.
Okay. Okay. Thank you.
Okay.
Okay. Thank you.
Hello. Hello, ma'am.
Yeah. Hello,
Ma'am.
I can hear you.
Good morning, ma'am.
Good morning.
This is Padmavati from Wales University, Chennai, ma'am.
Yeah.
Actually, I'm doing my research in dynamics, how the COVID is transmitting. And I have a doubt in making a model, ma'am. Actually, I would like to plan. My model should be applying electromagnetic force on my plasma between throat and red blood cells. So I'm struggling to make it a model, ma'am.
But in that case, you will have to use control state equation. To my knowledge, because I have never worked in fluid dynamics, okay? But I have some idea that if you go with the control state fluid Navier-Stokes equation,
Navier-Stokes equation.
You can get some results.
Yes, ma'am, but I have a problem whether I can apply my electromagnetic force or not. Should it react? The inactivation should be increasing or decreasing. I just want to know, ma'am, because this is a very new disease.
To be very frank, I have not read it, so I can't comment on it, because whether on which side you will be putting your electromagnetic nature, that's question mark. At least I don't have any idea about.
Okay, ma'am.
Sorry.
Hello, ma'am.
Madam, good morning. Madam, good morning.
Good morning, ma'am.
Good morning.
This is Vishwanath from Tech University.
Yes, sir.
I have a question.
Yeah.
Madam, I think in the brief introduction about you, Geeta Madam told that you are working in inventory theory also.
Yeah.
So now in the COVID-19 research, how far it will be helpful with the inventory models? Just to give an eye opener for me. Okay.
Doctor, actually basic research, my basic area is inventory. Okay. But since 2012, I'm working in dynamics of infectious diseases also.
Okay.
Now I will try to correlate inventory and what happens in such scenario, like what we had in lockdowns. Okay. Now I will take care of that. And obviously, I had recently I had one session in MDMI. That was about the disruption of supply chain. Okay. Now I will be putting disruption and this COVID-19 transmission and correlate them.
Okay, thank you, madam. Thank you. Okay. So, better can we talk with you in your mail and the contact?
Yeah, sure. I will be happy to respond to you. I will be happy to respond.
Please. Thank you, madam.
Sure.
Thank you.
Sure.
Hello, ma'am.
Hello.
Meenu from Anand. Ma'am, good morning.
Good morning.
This is Vijay Lakshmi.
Yeah.
Ma'am, I just want to know, are you using any fitness function, ma'am?
Pardon?
Are you using any fitness function, ma'am?
No. Because I'm using deterministic version. I already have calculated all parameters, so I'm not using any fitness. Any fitness function I'm not using.
Okay, but what about the convergence criteria of anything? Suppose we design any algorithm for this particular concept?
Madam, in my presentation, we had already convergence I can have using software. And it says it will converge, but it will not convert to zero. It will stay with us. So take this COVID-19 as one of your good friends.
Okay, ma'am. Thank you, ma'am.
Okay.
Mainan from Anand Institute of Higher Technology, Chennai.
Yeah.
I would like to know about the assumptions made in the model, madam. Is the total population treated?
Madam, you are not audible.
Hello, is the total population treated to be a constant?
Yeah, Indian population total.
Total population. So we have no immigration taking place, right?
No. Because I said that we had this research finished on April 2nd, so we were not having any immigration.
Okay, so it is treated constant, fine.
And secondly, madam, we don't have to consider because my model is taking care of only those elderly people. And so I said twice that 40% of Indian population is falling under elderly one.
But to our surprise, we are seeing many youngsters also passing away due to COVID, especially in Tamil Nadu. Yeah. We have below 40 also, there were several deaths which has taken place.
Huh.
So that was my concern. Number two is, I would like to know whether the transmission rate of the infection, the medication which you're taking, is it treated as a constant again? Your beta.
It varies from day to day. Okay. So from March 2nd to April 2nd, we calculated reproduction number, and then I said 5.35 in my calculation. Okay. So that will be taken as a constant on April 2nd. It will not remain constant.
It will not be a constant.
No, at present it is in one of the webinar we will have this number to be 83.
So we can play as a mathematician. We can play a role on in the reproduction number, in reducing the reproduction number in terms of through social distancing and washing hands. But we cannot touch upon the recovery rate, right? Because they are already infected.
Yeah, recovery rate is not under our control. But when you apply different controls, it can be reduced. It can be reduced.
Okay. Thank you. Thank you.
Okay. Okay.
Participants, any more queries? Okay then. I hope. Yes.
Hello, ma'am.
Yes, ma'am.
Good morning, all of you. I
Good
want to
morning.
know, ma'am, whether this model is applicable when the lockdown is open or not.
If you follow all the rules and regulations given by central government, I think this we can maintain, and that is what our responsibility is. We should maintain it.
You mean the model will be working after the lockdown period is stopped?
Yeah.
Okay, ma'am. Thank you.
Okay. Geeta madam, one request. This paper will be available from July 1st on in international journal, because I can see that in chatting everybody is asking for presentation.
Yes.
So yeah, but this model will be published in latest by July 1st in International Journal of Dynamical System by Hindavi. So and it is open access, so everybody can enjoy it.
Okay, ma'am. Okay. Thank you, ma'am. Like, I hope madam has covered her modeling, mathematical modeling, by touching upon why this modeling, findings of the modeling, what are the given items in the modeling, how do we assume it, and what is the prediction for the model, how to validate the model, and also after that how to verify it, and still after that how to improve and how to use it further. So thank you so much, ma'am. Thank you so much.
Okay.
Participants, I also thank everyone for being here for the past 1 hour and enjoying the session. Thank you, and I request you all